Now Ajit will tell him something about plasma. Thank you.
Hello everyone. I am going to tell you about plasma. What is plasma? Plasma is a state of matter. There are two concepts about the states of matter. One is the ancient view and the other one is the modern view. According to the ancient view, there are also four states of matter, and according to the modern view, there are also again four states of matter. Ancient view, earth, water, wind and fire, and according to the modern view, solid, liquid, gas and plasma are the four states of matter. What is plasma? Plasma does not have a definite shape or a definite volume unless it is enclosed in a container, just like as gas. All the stars are made up of plasma, and even the space between the stars is filled with a plasma. Plasma etching. Plasma etching is a form of plasma processing used to fabricate integrated circuits. Plasma generation has a major role in etching, sputtering, ion implantation, photoresist stripping and PEC making. Plasmas used in microfabrication are low temperature, low density plasmas as compared to welding or fusion plasmas. In microfabrication, high density plasmas means ion density in excess of 10 raised to the power 11 per centimeter cube. Plasma etching has a very high number of parameters that need to be controlled, which makes plasma etching more difficult both experimentally and simulation wise. Machine parameters affect plasma parameters, which together with the surface reaction determine the final outcome, which is the rate, selectivity, anisotropy, uniformity and damage. Here you can see that these are the machine parameters, also called reactor parameters. These power, frequency, pressure, flow rate, temperature affect plasma parameters together with the surface reaction parameters, and then they determine the final outcome, which is the H response. H response include rate, selectivity, anisotropy, uniformity and damage. Direct plasmas. Plasma etch reactors can be classified in a various ways, and the following is just one. A parallel plate diode reactor with two electrodes, one powered and one grounded, is a basic construction of an etcher. This is a parallel plate diode reactor. On one electrode, which is powered, vapor is placed, and the other one, gas is introduced. Direct plasma. It is called RIE, reactive ion etching, when the vapor is on the bias electrode, and plasma mode etching when the vapor is on the grounded electrode. This is the bias electrode. Vapor is placed on the bias electrode, so it is called reactive ion etching. The vapor is placed on the grounded electrode, so it is called plasma mode etching. Vapor are placed on electrodes that produce the plasma. Plasma density, sheet voltage, ion bombardment that hits the vapor are thus dependent on each other and cannot be controlled independently. Direct plasma. Despite this seemingly inconvenient state of affairs, this arrangement is very widely used because of its simplicity. 13.5 MHz RF generators are used to create plasmas of typical density 10 raised to the power 10 per centimeter cube. In remote plasmas, plasma generation takes place in a region outside the vapor. It's not the same as in the direct plasma. And the vapor sees a controlled flux by, for example, a separate bias power source. Alternatively, the vapors may be shielded from ions completely by a Faraday cage. Because of this decoupling, high density plasmas 10 raised to the power 11 to 10 raised to the power 12 per centimeter cube can be achieved without high sheet voltages or severe ion bombardment on the vapor. Since high density of ions and radicals means a high concentration of active species, high density plasma offer higher etch and deposition rates. VRIE reactors use inductively coupled plasmas and employ 2 to 5 kilowatt power sources for plasma generation. Higher etch rates, lower damage, easier photoresist removal and higher selectivity favor high density plasma reactors. Remote plasma reactors are often difficult to scale to large diameters because of the physical separation between plasma and vapor. Whereas in parallel plate reactors, the plasma is naturally aligned to the vapor. But larger vapor size make direct plasma reactors less attractive. In order to maintain the same size, same power density, the absolute size of the RF generator makes them grow far too big.